Optimization. A word which strikes fear in the hearts of some, confusion in the minds of others. What is it? How is it done? Why does my scene of simple cubes run slower than some of the most visually impressive games out there? Now, if you look up videos on optimization, oftentimes you end up in one of two categories. One, where techniques are so obvious you regret clicking on the video in the first place, and two, videos so technical you're left scratching your head wondering what the heck a flame graph even is. Optimization tutorials in general, although well-intentioned, can oftentimes defeat their own purpose as well. It's often the case that frame rates are artificially reduced through a means the artist or programmer already knows how to fix. And it is often demonstrated in a scene which might have nothing to do with yours in the first place, and you end up in a situation where you're trying to fit their square peg in your... Don't make me say it. Today, we're not doing any of that. Whereas you might have grown accustomed to creators handing you fish, I'm handing you the rod and you'll be learning to fish for yourself. That's right, we're going to be breaking down just about every way we in the industry optimize our scenes, what the view modes and profilers mean, common hiccups you're likely to run into along the way, and how we go about fixing it. This is part one of a multi-part series, so let's not waste any more time. Now, before we jump into the engine, we're going to go over one of the most important parts, perhaps the most crucial part of optimizing any game, and that is the planning of the game. Now, as I've stated in a previous video, optimization is not something you do just at the end of your game. It's something you're going to be doing throughout the entire process if you're doing it right. Starting at the beginning of the process, the planning phase. Now, a lot goes into planning the game. And some of the questions which I find a lot of developers don't ask themselves too often, and it's perhaps one of the most important questions that you should be asking yourself, is what is your target frame rate? Not every game is built to be 120 frames per second. Not every game is even built to be 60 frames per second. So knowing what your target frame rate is can help to really define the sort of workflows and the pathways forward. If you are looking to do, have a game be 120 FPS, then that's going to really change your workflow and the types of assets you're going to be developing, the sort of quality you're going to be putting into it, as opposed to, let's say, a cinematic game aimed at, being just a little bit above 30, like around 45 frames per second or something like that as a target. Now, obviously on PC, you might get higher frame rates, but as far as target frame rates, so 120 frames per second, that's really going to define your game. It's probably going to be really simple. You're probably going to want to use baked lighting, and you're probably going to use LODs. If you are doing 60 frames per second, then the geometry is probably going to be a combination of simple and complex. You're probably going to be using trim sheets, for both 60 frames. Well, really for all of them, because trim sheets are just great, but just to give it a mention here, you're probably going to be using trim sheets. Baked or dynamic at 60 frames is really going to be an aesthetic choice, as well as certain dynamics that you might have. So if you want a full day-night cycle, that's easier to do it with dynamic. But 60 FPS at least allows for dynamic, right? And then if it's going to be lower than that is going to be something looking to be very cinematic, something like Hellblade 2, Senua's Saga, something that's almost like a borderline tech demo sort of thing. And that's something where, so I'll just put in 45. I know I'll probably get some people laughing at me, no game's optimized for 45, and you're probably right. But if you're looking for, let's just say, to create a really cinematic experience for a game, you're going to put in all the details, then that's when you might start putting in Nanite foliage, at least for this current instance, because world positional offset is so heavy. And you're probably going to be using, full geo and, other things, right? You're basically going to be packing, the scene with detail and probably with also high res textures. Res textures. It is important to note not to use those 8K textures, by the way, that that Megascan Nanite textures ship with. So 8K textures. Let's just cross that out. So right here, so what did we define here? So you're planning your game, you're trying to figure out what it's going to be. You need to pick and choose your battles. That's the first thing. Game development is a series of choices that you're going to make, and those choices often comes at a cost. It might come at the cost of quality. It might come at the cost of function. For example, you might be creating a first-person shooter that has a fully dynamic world. However, the systems in which you're using, doesn't really allow for full dynamic, right? You're not going to have like skyscrapers collapsing and stuff, even though, they did that in in Battlefield 4. But, let's say, just as an example, since we're here, that you're not going to be able to have that level of dynamicism. So you need to sort of pick and choose what level you can. And oftentimes, a lot of this just comes with test. So when you are early in development equals test period. So when you are early in development, make sure to be testing all these things. Some things might work better in the situation for your game. Every game is going to be different. Every game is going to be developed different. Every game is going to look a little different, going to feel a little different, going to use different sort of systems. It's really going to be just focused around what the developers really know and are best at. And those are going to be the pathways forward oftentimes. And when you're doing this, you want to test early. See if Nanite is right for you. See if Lumen is right for you. Or maybe, NVIDIA's, RTX GI is the right choice. Maybe you want to do baked lighting. Maybe you're going to do LODs. Maybe it's all going to be trim sheets, or you're going to use, like a per instance, variances and stuff like that. So test in the beginning, because when you're first starting, it's the best time. You're not too deep in. So let's say we did all this, or let's just say we didn't, right? This is an optimization video after all. If you're here, you might be running into issues with optimization. So let's actually jump into the engine and let's take a look at some of the common ways to optimize first. We'll get into the more complicated ones a bit later. Now, first thing we're going to look at are the different view modes, some of the more important ones, what are they used for, as well as some of the lesser used ones and why you should be looking at them. So we're going to come over here. So optimization view modes, these are going to be some of the first things you're going to look at when you have a low frame rate and you're wondering what the heck is going on here. So optimization view mode, we're going to start with light complexity. Light complexity is probably going to be the first one you are going to look at. And when you look up optimization tutorials, oftentimes, they just have a bunch of artificially just laid out overlapping lights, and then they just tell you reduce the attenuation radius and your scene will run fine. And those are the ones that always make me want to pull my hair out. But it's perhaps the most obvious solution, so we won't spend too much time with it. But light complexity, what are you looking for when it comes to light complexity? So what you're looking for is not too many white or purple spots like this. And as an example, I actually recorded a short, and in our little test village, I was running into weird performance issues that I wasn't really quite sure. So what did I do? First thing I did is I looked at the light complexity. And I mean, this is kind of a funny short, but which you're free to watch it. But as soon as I looked up light complexity, it started doing this. And I was like, whoa, what the heck's going on here? So this was actually from an asset I got from Fab. So again, always look at your Fab asset. But when we look at the light complexity, all of this here was really just caused from a single little light in here. So it's since been fixed, but I had this one little firelight, and the attenuation radius was gigantic. It was set to like 32,000, which is insane. You don't want that. So one, never do that yourself. Two, if you are making assets, if you brought assets in, check the attenuation radius on your lights and make sure it does not look like this. So light complexity, you want your scene to look like this. You want it to be as blue as it can be. You might have some green. You might honestly sometimes even have some purple and some white. A little bit every now and then, if you need it, is fine. When it comes to your scenes, you want to, of course, optimize. You want to make sure everything's running. If things are running, you might have the bandwidth to, make an area look a little bit nicer, make the lighting a little bit more complex. And, that being said, a little bit goes a long way. Do it very sparingly. But, just one of the common view modes, light complexity. So the way to fix this with light complexity is either A, delete lights, B, turn cast shadows off, or C, just reduce the attenuation radius, the area of effects. 9 times out of 10, if you are having issues with light complexity, your lights are probably going to be overlapping too much anyway. So for example, like let's say this was a lantern, you don't need your attenuation radius to be like this far. Or let's say there's a light that's going to be this intense. It's not even casting this far, but it is going to calculate this far. So make sure to tighten up this attenuation radius to only the area it's affecting. So we're going to move on into shader complexity. So shader complexity, your scene should look, for the most part, green. It's not going to always look lime green, like the really bright green where it's like really good and the engine's really happy with you. When you're using transparencies, you're using water, you're using fog cards, you're using smoke, you're using windows, for glass. That is going to increase the shader complexity. So when it comes to those and you're thinking, well, how do I reduce the complexity? You don't. It's just because of the way the engine sort of renders transparencies, it's going to be more expensive. So when you're looking at this, things to look for more so is how complex is your landscape? How complex are your shaders? Now, this is where the, pick and choosing your battles comes in. Maybe you have so for example, these materials, they're super simple. There aren't any masks, any procedural, anything going on. It's just textures into the material with maybe a few parameters. That's it. But when you start adding layers, when you start adding procedural systems, maybe like a procedural sort of like Rust, or maybe you have some system where like it rains and then the rocks get all flourished green or whatever, or they start oozing blood or something crazy. Because those are your choices for your game, then you're going to look at this and you are going to have more complexity just naturally. There's no real way to take your shader with a bazillion layers on it and make it have like zero complexity. That's not how this works. Optimization, among other things, and most importantly, as it should be stated, is a series of choices. Some things you're going to choose as things that are going to hit your system harder than others, and that's just how it is. That's why you might see games where some things might look beautiful. Perhaps the atmospheric effects and the lighting and all that is just gorgeous. The actual like rendering of it is beautiful. And then you stop and you stare at like the textures, and the textures are like, they're like 512, resolution. They just look like blobs if you stare at them for too long. These are just conscious choices that you as a developer have to make. And it's the choices that, we make all the time. But shader complexity, there are ways to reduce complexity. Contrary to what I just said, kind of. Like, yeah, you might not get your shaders to look lime green like this if they're super complex, but there are plenty of little things you can do to reduce the shader complexity. And I'll show you one example of a system we're developing and how I reduce the complexity a bit on that. So here I have this little look dev scene I threw together, and I've been look deving some armors. All this is still very early on, work in progress. Things are probably going to change. But we have a procedural sort of wear system for, Rust and things like that. And so I'll just sort of scrub through this real quick to kind of show how that looks. So I've just been, again, this is just look dev. So seeing, how it works, even sort of cutting up the bottom of that a bit, wearing it a bit. So with something like this, the inclination might be to use a bunch of different textures, right? Like a texture for each thing. You get a texture and you get a texture. But if we actually look here at the shader really is just we have the mask, which is something I made in Substance Painter, which if you guys are interested, I could always make a tutorial about this as well. But it's just, oops, turn those all back on. But it's just the different, the wear, the edge wear, the rust, and then the sort of outer wear. And I do have one that is the rust texture, but the rest really are just colors. So instead of using, one texture, like a different rust texture per thing, I use one rust texture, not using too many parameters, just to control the, the saturation, brightness, contrast, the tint. And then here, I'm basically sampling this. And then for the scratches, the edge wear, instead of creating like a different sort of material for that, I'm just taking that, sampling it, and then just completely desaturating it, and then reducing its, and then increasing the metallic and stuff. And then same with the discolor layer, same sort of thing, just taking the base color and just adding a tint to it. And that's really all that's going on here. And then this is just blending. So we have these different outputs, blending. But yeah, so this, looking at your instructions, it's about, 563 instructions. And you want to keep those instructions as low as you can. So it's going to be red. It's going to be a darker red, which is fine. Like it's going to be complex. And again, this is where the sort of series of choices comes into play. If this is a system you want, then, we allow this to run. We reduce the complexity as much as we can, but we can only reduce it so far. And essentially what you want to do is get to a point where you're balancing the sort of optimization of it with the look of it. So if it looks how you want, try to reduce the optimization as much as you can without completely destroying the effect that you're going for. And sometimes you might end up with the complexity that looks like this. And in that case, then it's fine for what you're going for. That's why optimization is a very specific thing. It's very specific to you. For your project, this level of complexity for your materials might not be fine for the characters. But for others, this might even be a little too low. You might want even more systems in it. So, it's just give and take. You pick and choose your battles. So we're going to go back here. And the next is going to be, we can look at quad overdraw. Most of you are probably going to be looking at Nanite Overdraw. So we'll talk about it more there, but essentially to get a little bit ahead of that, what overdraw is, to sort of break it down in the simplest way possible, is the engine renders what's furthest away first, and then it starts rendering everything in front of it until it's rendering the closest thing. And so because of that, the more stuff you have sort of in front and sort of stacked on top of each other, the more overdraw you are essentially going to calculate. We'll go a little bit deeper into that in a minute. Another one that isn't used as much and is very much slept on really is this required texture resolution right here. So by default, it does not render nanite. So I'm just going to take this rock and reduce that. And so now when you're looking at required texture resolution, at first it'll show this. It'll be black. It'll say undefined. And so what you need to do is actually select a texture. So this one, for example, the diffuse. So one thing that virtual textures is really good at is streaming the sort of level of detail for the texture that you need depending on the distance from it. But if we look here, it'll tell you if you're 2 times over, if you're 1 times over, if it's white, it's good, 1 times under, 2 times under. and that's going to be dependent on the distance from camera. So to know really what works for you is really going to be dependent on the kind of game you're going to be making. So if you're going to be a first person game, for example, and you're going to be able to get like this close to a given asset, or let's get something that has a bit more light on it, you're going to be able to get like this close to a given asset, then the texture quality that you want to be streaming might be a little bit higher potentially, depending again on what you're going for, than if your game is third person and you're only getting like this far. So we don't really need super high resolution up close textures, right? You're not going to be needing 4K on everything, and reduce those 8K textures on your Megascan Nanite assets right now, because you're never going to be needing 8K unless you're doing some gigantic single piece thing. Even then, still, just don't do it. Just don't. From here, we are going to be looking at Nanite visualizations. Specifically, there's two that we're going to be looking at. And first one is going to be overdraw. This scene has a lot of overdraw. And one of the primary, so a few reasons. One is these barns they're made up of too many compartments for Nanite, in my opinion, as we can see here with all this overdraw. So if you're building a house with like individual planks, then you're gonna have a lot of overdraw because it's rendering, again, every mesh sort of in front of each other. And so if you have, every single plank completely separate, then it's going to render those on top of each other, and you're gonna get something like similar to this going on. So what you wanna do is, like, it's fine to first build out, if that's your process, it's fine to set them up like that. But then once you're done, just group them together, like grab the planks, just tools, merge actors, and just merge the actors together, or keep them in an organized folder as well. But just make sure that you're merging actors when possible if you're building that way, so that way you reduce the overdraw. Now with foliage, the reason this has so much terrible overdraw is because it's masked foliage and not the Nanite optimized foliage, which we already did a video on that if you want to watch it. We just did that one. But with the masked foliage, Nanite really doesn't like it, as you can see here. And part of it is because there's just a lot of this excess sort of geometry that's not even being rendered, but it is being calculated in overlap. And just with the way these are with just overlapping geometry in general, the engine has a hard time sort of calculating it. So the way to reduce overdraw, if you're using LODs, so let's say you're looking at this and you're saying, well, I'm not using that silly Nanite foliage pipeline. So, I'm using regular overdraw and, I'm using quad overdraw. So if that's the case, which is perfectly fine, you don't have to use Nanite foliage. If you're using LOD foliage and you're using this view mode and you're looking at it, the way to optimize it is with LODs, pretty much. LODs and potentially just reduce density as well. But the LODs, to reduce the sort of pixel per sort of screen inch, if you will, which is really what you want to be reducing. So you want to reduce those LODs. You want to make sure that you are using LODs for foliage if you're not doing Nanite foliage. How do you know what those LODs look like and if you're using them? It's going to be over here in this LOD, or level of detail coloration, mesh LOD coloration. So again, the foliage right now is not Nanite, and right now there's like the waterfalls and the windows are, for some reason. But as we see here, as we get like closer to these, gray means LOD 0, red is LOD 1, and then green is, LOD 2, and then blue is LOD 3, and I think it's like, I can't remember LOD 4 off the top of my head, but essentially this will tell you like the level of detail for the distance that you are at. So if you're using LOD foliage, which, if you don't need Nanite foliage, I do suggest using LOD foliage. And if that is what you're using, be sure to look at your LOD coloration. Make sure that you don't have some rogue piece of foliage that's just LOD 0 to infinity. Especially if you've tinkered around with like turning Nanite off and on your foliage, you might have that. So be sure to if you revert your foliage back to LODs from Nanite, make sure to check this. And and then to optimize for Nanite Overdraw, one is just merging meshes, and when it comes to foliage, making the full geo foliage. That being said, I do want to say you are always going to have a little bit of overdraw, especially with foliage. You're always going to have a little bit of overdraw. Your foliage is like rarely, if ever, like if you have dense clusters of foliage, it's never going to be this where it's just like zero overdraw, because you are going to have, meshes that are of different types overlapping, like via the screen. So a little overdraw you're going to have. Overdraw like this, you don't want to have. So just clustering things together, Nanite, make sure it's full geometry. LODs, make sure you're using LODs. Another one in here that is not often looked at, it's very underestimated, is the raster bin. So what a raster bin is the technical definition is basically like a series of pixels that share like the same rendering state. What that means is basically the assets in your scene that essentially like share the same asset type / like material. So as we see here, all these sort of rocks, all these sort of opaque assets here, they all share the same bin. And when you open this is what you want to see. Like we'll talk about the foliage in a moment, but this is what you want to see with your solid objects. You want to see all of them, at very least most of them, sharing the same bins. Now, what might happen when you are, let's say you're downloading a bunch of packs from Fab, and what you're creating essentially, even if it's just for right now, essentially just a collection of a bunch of Fab assets, and you're just throwing them all in. And then you go in here, and these are all like mismatched different colors. How would we fix that? What you want to do is make sure that everything is kind of sharing like the same material if possible. Like when it comes to foliage, for example, and this will be a tutorial a bit later, but one thing you want to do is sort of pack these the textures, as many textures as you can, sort of categorically, into sort of UDIMs, and then use per instance variations instead, as opposed to having like completely separate materials for foliage. So if we look at the foliage here, you see they're all sort of different colors based on categorically like what they are. And that's what you're going to see by default. And the way to fix that, again, if you're using the Nanite foliage, is to sort of categorically clump them into UDIMs, and then make sure they're all sharing the same material, and just use like per instance variables, basically. And I'm working on a tutorial about doing just that, so stay tuned for that. But yeah, raster bins, they're very slept on, and they're very important, so be sure to look at them. The last one here, as far as view modes, is just going to be the virtual shadow maps and the cache page. So we're going to look at another scene for the virtual shadow maps, which is going to be the cached page. So we're looking here, and we're looking at the cache page. In Unreal Engine 5, this is going to be gray as like the default what's best. In Unreal Engine 4 and prior, which is what this is running on, is Unreal Engine 4, it's going to be green is what you want. So here we have it green, and we have some blue areas as well. So generally speaking, the biggest culprit with this is going to be your foliage 9 times out of 10. So just make sure that when you're looking at your foliage here, make sure that your foliage, when you scroll down under instances and settings, that your invalidation behavior is always either rigid or static. By default, it is set to auto, and you can see some of these assets that we painted down. Now they are invalidating our shadows a bit. And so what this means is that the GPU has to work harder to calculate these shadows because they're constantly in flux. So, and this is based on world position offset. So basically with auto, if you have it at auto, what that means is like when world position offset happens, that it's going to cast those lights dynamically. So, you'll see like the actual shadow of the tree swaying, for example. If it's set to like rigid static, it's not calculating that. So if that's something that's really important to you, where you're going to have, trees that sway like crazy, you have like maybe it's like a storm simulator, maybe you do want those shadows. So in that case, you might keep it at auto and then you optimize for something else. If you're doing that kind of game, don't use nanite foliage just because of the hit on world position offset. But yeah, so rigid, static, again, you can use auto, but if you want to make sure that you are not invalidating that, just go into rigid and static. There is an issue that I've run into, kind of a bug, where the dynamic or the directional light might just be invalidating the scene. It happened actually in this scene, which is why this is directional light 2 and not just directional light, where I basically had to just delete the first directional light because it was just constantly invalidating. As any game developer knows, Unreal Engine, it's a game engine. It's a buggy mess. Things happen all the time that just should not be happening. So that might happen. And that might be what's happening here. And so to recap, light complexity is going to be the view mode that you're going to use to troubleshoot your lights. Common fixes is going to be reducing attenuation radius, reducing light overlap, and possibly even turning off cast shadows on some of the lights. View mode number 2, shader complexity. This is going to show your material complexity. How many layers is it? How many parameters? How many instructions are running? Now, the way to reduce this is to reduce the amount of parameters in your material, reduce the amount of textures and layers in your material as well. Sometimes your materials are going to be complex, and if that's the case, then you might want to optimize around that. Also, keep in mind that translucent materials are going to always be complex materials, so keep that in mind. We have quad overdraw. If you're using LODs, you're going to be using quad overdraw. What overdraw is, again, is the way in which the engine renders the assets is going to be from furthest to closest, and the more you have sort of overlapping each other, the harder the engine is going to have, the harder time the engine is going to have with that. And things that will hurt this will be things like fog cards, too much overlapping mask geometry. And the way to fix this is reduce transparencies and using LODs. Now, the other one that we went over is required texture resolution, which is the resolution of the textures that you should be using for your assets. So this would be things like removing 8K textures from your scene, and even for things like small props should not be 4K textures. Maybe even just using like 1K or 5K or 512 resolution textures for a lot of assets. Generally speaking, for a video game, you generally don't need to really go over even 2K. The difference between 2K and 4K isn't really that noticeable. Maybe on a really large asset it might. And if that's the case, then just do the test. Raster bin. So the raster bin are the assets with shared materials, the sort of shared types of assets with shared materials. The fix for this is going to be grouping assets using the same materials. And this would be, for example, if you want variances, such as with foliage, then you might pack the textures into UDIMs and use per instance variation instead of using a bunch of different material instances. So that would be the fix. What to look out for would be assets of the same type that have different coloration, because that means they're going to be rendered in separate bins, and that's not good. Next is virtual shadow maps, specifically the cache page. If you're on 5.5, make sure that this is going to be gray. If you're on 5.4 and before, make sure that your scene looks green. What this is looking for is how many times, basically like per second, per millisecond, that the system is calculating the shadows. So like in real time, like the dynamic shadows, how often are they being calculated? And what you want is as much green if you're before 5.4 and as much gray if you're on 5.5 and above within your scene in this mode. And the biggest culprits of this is going to be world position offsets with dynamic shadows being cast. The fix for this is to go to the foliage and the invalidation mode, set it to rigid or static. The drawback to doing that is that it will not render dynamically sort of swaying shadows. It is important to note that optimization is not just some wand wave to just poof magically fix all these issues, and it is rarely the case that you're going to just click a checkbox and magically get max frames. Be sure to also stay wary of tutorials claiming to do just that. However, a simple watch tends to just kind of tell you why. Optimization more often than not is detective level work. It is simply going through the motions step by step and watching your frames steadily increase towards your target mark. Now that is it for part 1. I know it was a lot of water, probably treaded already for a lot of you, but I'll be pushing these ones out real quick. It was important to start with fundamentals to make the next areas of optimization more simple to go through. In part 2, we will be going over the profiler tools, what they do, what they mean, what they look for, and how to fix the issues you might be running into. So stay tuned for that. I hope you all liked this video, and until then, I'll see you in the next one.